Hey guys, welcome back. Today I'm going to add just one more itty bitty little type of problem to your related rates work. Okay, take the time to read this problem, draw a picture, visualize it. Okay, mulch is poured through a chute on I-75. Does that happen? Sure. When they're clearing the road on the side of the interstate and they're trying to cut down the trees, what happens to those trees? They cut them down, they throw them in a chipper, and when the trees and the chipper and the mulch comes out of the machine, it makes a pile, a conical pile. But different from yesterday, when that happens, the conical pile is going to be such that the base is the circle. Okay, so this time your conical pile is going to be shaped like this. Okay, so the bottom is the circle because you're making a pile of mulch. Okay, conical pile. All right, mulch is being poured or shot through the chute, whatever, at a rate of 10 cubic feet per minute. Hold on, just messed something up. Okay, so that's a rate. What rate is that? Well, what they're trying to tell you is that dV dt is 10. And remember, the clue is cubic feet per minute. That's telling you how fast volume is changing. Cubic feet means volume. All right, what else do we have? It's falling into a pile, into a conical pile whose bottom radius is always half the altitude. The bottom radius is half the altitude, but they're both changing as that mulch gets bigger and bigger into a pile. They're both changing, but the radius is half the altitude, 1/2 h or h over 2, either one. What this is going to be used for, by the way, this is going to end up making it so we can get rid of one of the variables again. All right, well, this one's a little bit of a stickler here. Okay. How fast, that's a rate, how fast will the circumference of the pile be increasing? How fast is this changing? Circumference of a circle. Well, circumference of a circle is 2 pi r. And what they're really asking for is how fast is C changing? They're asking what is dC dt? That's the question. Okay, well, let's just start with that. I mean, they gave me dV dt, so I should need volume, but right now, I don't really need it yet. What I need to know right now, they want to know dC dt. So I can do that. All right, derivative. There's only one variable on the right. This is easy. The derivative of C with respect to time is dC dt. On the right side, this is just one variable, so it's a power rule, 2 pi dr dt. Okay, well, they want dC dt. That's the question. So I need to fill in 2 pi. I must know dr dt. I look around. Aha, there's the problem. I don't have dr dt. I have dV dt. So the piece that I need, my missing piece that's going to go right here, is dr dt, and that's not given. So I'm going to use what is given to find it. Well, if I want to have dV dt in the problem, then I need to go backwards and find volume of a cone. Okay, so I have volume equals 1/3 area of the base times the height. Keep in mind what we're trying to find, though. What we're really missing right now is still dr dt. Dr dt is what I really need so that I can answer the question that was asked, dC dt. Okay, well, now this brings us to the same spot we were in yesterday. I have too many variables right now. I have a v, an r, and an h. If I keep all those variables, then I need a dv, a dr, and a dh, and I won't have enough information for that. So, again, focus on the rates that are given and asked for. dV dt is given. dr dt is what I actually need. So I want to keep v's and r's. So I need to get rid of this h, and that's where this guy comes in. Solving h, if we solve that for h, multiply by 2 on both sides.
Seniors, attention seniors, remember that
And we'll get
your picture day is tomorrow,
h is equal to 2r.
October 21st.
So now I can replace h with what it equals.
Dashboard for information on making an appointment and what to wear.
Replace h with 2r. Simplify. We're going to have a 2 times a 1/3 is 2/3. And there's an r squared times an r. Okay, so again, focus on what we're trying to find here. Remember, the question was, what is dc dt? But we couldn't find it until we knew dr dt. So what I really need right now is dr dt. Okay, so now we're pretty much where we were at yesterday. Okay, now we're going to need to get dr dt into the problem. So we're going to take the derivative of both sides. So the derivative of the left is dv dt. On the right, I have a power rule. 3 times 2/3 is 2 pi r squared dr dt. Now I can fill in this moment in time. dv dt was 10. R, I don't know if they gave R, but even if they gave H, I can still find R, so no big deal. Let's see what they gave us. The pile is 8 feet high. So they gave me H is 8. But if H is 8, plug that in right here and we'll find R must be 4. Square it. dr dt is what I'm trying to find in order to answer the actual question they asked right here. So divide by, get dr dt by itself, divide by 32 pi on both sides. And now I have what dr dt is. dr dt, if I simplify that, is actually 5 over 16 pi. That's what I need, believe it or not, to answer the question. Now I can put the 5 over 16 pi here, and I can answer the question they actually asked. Okay, so one final step. Multiply that out. The pi's will cancel. I can cancel the 2 and the 16. I'll get a 1 and an 8. So I get just 5/8, and that's dc dt. And since that's circumference, it's like one piece of string going around the circle. So my units are linear, and it's just feet per minute. Now that's pretty much as bad as it gets. That's the answer to my question. But let's go back through what we had to do, okay? I think the key for this one, start with the question that they asked. They asked for how fast circumference was changing. So I started with circumference, and I started by doing the derivative of circumference. But as I did that derivative, I learned I didn't have the missing piece that I needed was dr dt, and I needed that and didn't have it. So then I went, oh, but they gave me dv dt. So I then used volume to get dv dt in the problem. And then once I had dv dt, I could find dr dt. That's pretty involved. That's as bad as it gets, guys. Please, please, please watch this again. And also know that this is a higher level problem, but you can do it. I know you got this. All right, good luck. Bye.